Good day, everyone. So today we are looking at a question in NECO for mathematics, and it happens to be question 6, which fall under friction. It says a particle of mass 36 kilograms slides down a rough plane inclined at an angle of 60 degrees to the horizontal. So if the coefficient of friction is 0.4, find the acceleration of the particles correct to 2 decimal places. We are given g as 10 meters per second square. So there are things we have to look at for here. You need to get the weight of the particle if the mass is 36 kilograms, and say the angle is 60 degrees to the horizontal axis. That is how the plane is inclined, 60 degrees to the horizontal axis. So let's draw the Fox system or the diagram to illustrate what the question is telling us. So let's consider our horizontal axis first. So let's assume this is the horizontal axis, and let's call it x. So the particle is inclined at 60 degrees. So from here to here, let's take from here to here 60 degrees. That is why the particle is not inclined. Please note, this diagram is not drawn to scale. So here is now 60 degrees. So let me call here A and B. A, B now simply represent the plane. So the particle of 36 kilograms is resting on the plane. So let's indicate the particle now on the plane. So let's take here as the particle now is here. So let's say this is now the particle, and the mass of this particle is 36 kilograms. So that will now give us the weight of the particle. The weight is simply 360 Newton. Why? Because weight is simply mg, which is now 36 times of 10. The weight will give us 360 Newton. That's not the weight. So I can draw the vertical axis at this point. So if here is 60, here is 60. Reason is corresponding angles in plane geometry. So with that, I can now resolve this particle down, this 360 weight, into the vertical axis. If I resolve to the vertical axis, that will give us 360 cos 60 degrees. Then I also resolve this particle now into the horizontal axis. If I resolve to the horizontal axis, that will give us 360 sine 60 degrees. So how do we know this side is cos, this side is sine? It's fall under the topic is resolution in physics. I have a video of that in our channel, so you can go back and watch why is 360 cos 60 and 360 sine 60. So normal reaction will oppose this weight acting on this body. So normal reaction will oppose it. Let's represent the normal reaction as arrow. This is not the normal reaction. We oppose the weight of the particle. So since body is sliding down, according to the question, so the body is sliding down. This is 36 kilograms sliding down. So that's why it's moving this way. Frictional force will oppose that motion. That's one of the laws of friction. Frictional force opposes direction of motion. So we agree that the body accelerates in this manner. So here is now my A. So this is now the free body diagram of the question given to us. So we also given frictional coefficient of friction from the question as 0.4, and is represented as mu, symbol for coefficient of friction, at 0.4. So with that, we can now see that the body is at equilibrium. This body is at equilibrium. So clearly the body is at equilibrium. There are conditions for equilibrium. For a static equilibrium, 1, sum of all the forces acting horizontally must be 0. 2, sum of all the forces acting vertically must be 0. What happens if the system is dynamic? That means involve acceleration. In that case, my summation f of x now will no longer be 0, but what? Ma, mass times acceleration. then our summation f of y is 0. So we are going to consider these two conditions. Summation f of x is now ma, while summation f of y is 0. So who are those acting horizontally? You can see the frictional force here is acting horizontally. This force here is acting horizontally. Then the mass and acceleration. So according to sign convention, if the arrow is acting upward, it's positive. Acting to the right-hand side is positive. Acting downward is negative. Acting to the left-hand side is negative. That is sign convention. So you can agree with me, frictional force is positive, while the 360 sin 60 is negative, positive, negative. So I'm going to have F, I'm going to have now F minus 360 sine 60 degrees is equals to MA, is equals to MA, M and A, which is 36A. So I can make F the subject formula. Let me make frictional force the subject formula. So my frictional force will give me 36A plus 360 sine 60 degrees. Let's call it an equation. Why is it so? F is unknown, A is unknown. So second condition is summation f of y at 0. So I will consider the second condition, summation f of y at 0. So who are those acting vertically now? You can see the normal reaction is vertical. First, the downward force here is also vertical. But the normal reaction, according to sign convention, is positive, while the downward force here is negative. So I'm going to have r minus 360 cos 60 degrees equals to 0. So my r will be 360 cos 60 degrees. So r will give us 180 Newton. So let's take that as equation 2. Let's take that as equation 2. So our arrow now is simply 180 Newton. But from another law of friction that says frictional force proportional to normal reaction. So if I want to remove my sign of proportionality, this now implies that frictional force is now mu r. So what is our mu given from the question? Is 0.4. So with that, we can now find our frictional force. So my F becomes 0.4 times 180, which is equals to what? So if you multiply 0.4 times of 180, that will give us 72 Newton. So let's substitute F now into equation 1 to find our A. So put F into equation 1 so we can get our A. So if that should happen, we're going to have 72 is equals to 36A plus 360 sine 60 degrees. So 72 will give us 36A plus, so what is 360 sine 60? That will give us 311.76. So to find A, I will simply collect like terms from here. So I'm having 36A equals to 72 minus 311.76. So 36A is equals to 72 minus that will give us minus 239.76. Therefore, our A is simply minus 239.76 divided by 36. So our A will give us minus 6.66 meter per second square. So therefore, A is now 6.66 meter per second square. I will indicate direction is negative, acting in the negative direction. So that is the answer to the question. Please always subscribe to our channel, support it to see an exciting videos such as this. Thank you for watching.